Hi, my name is Keely Rice in Lab 44 Group 1, and my group tested the effect of music on heart rate and blood pressure. My lab partners are Jasmine, Jen, and Jeremy. In Lab 21, we realized we spent too much time taking vitals after exposure to the music, and the vitals were returning to their basal values before we recorded the results. In Lab 22, we started to take vitals 30 seconds prior to the song ending so that we would accurately record the vitals during the song. We also allowed more time in between songs to allow vitals to return to the baseline values, as the vitals had not returned and were skewing the results in our experiment. Our hypothesis is that different types of music will modulate heart rate and blood pressure, while our null hypothesis is that music will not have an effect on heart rate or blood pressure. We also have two predictions for our experiment. Prediction 1 is that calm, mellow music will decrease both the heart rate and blood pressure by increasing parasympathetic innervation, putting subjects in a resting state. Prediction 2 is that loud, exciting music will elicit a sympathetic stress response and cause an increase in heart rate and blood pressure. Before running the experiment, we researched a little background information on our hypothesis. We realized that music had been shown to modify cardiovascular function, and these changes are broad and their nature varies according to the individual. In other experiments, it showed that these physiological changes are influenced by the style, tempo, melody, and rhythm of the music being played. And in previous studies, it had been proven that different styles of music led to changes in the blood pressure and the heart rate, and this might be related to the sympathetic and parasympathetic responses elicited in the subjects who are exposed to the music. In order to set up control for our experiment, 3 subjects were monitored for basal vitals via ECG, pulse meter, and manual blood pressure. A set of vitals included an ECG reading, a pulse, and the systolic and diastolic blood pressure reading. After control was established, subjects were instructed to concentrate on Beethoven's Moonlight Sonata via earbud headphones for 2 minutes. At the conclusion of the 2 minutes, a set of vitals was recorded again, while the music was still playing to fully immerse the subject in the music. The subjects were then allowed 5 minutes to return to their basal vitals, and the process was repeated again with the second song, Feeding of Nihility, by Disfiguring the Goddess. Vitals were recorded a minute and 30 seconds into the song, and the individual was allowed to rest after and return to their cool-down basal vital period. The results of our experiment were separated into 3 parameters: the systolic blood pressure, the diastolic blood pressure, and the heart rate. Percent change was calculated for each variable reading relative to the basal readings of each subject. We then analyzed the results using bar charts and an ANOVA statistical analysis, and each analysis was done on each individual in our experiment. Figure 1 shows that Subject 1 and Subject 3's heart rates decreased while listening to Beethoven's Moonlight Sonata, while Subject 2's heart rate remained unchanged. Figure 1 also shows an increase in all 3 subjects' heart rates while listening to Feeding of Nihility, and the heart rates increased dramatically from the basal values. Figure 2 shows that while listening to Beethoven's Moonlight Sonata, Subject 1's systolic blood pressure increased from the basal value, while Subject 2's blood pressure and Subject 3's blood pressure showed no change from the original basal value. While listening to the second song, Feeding of Nihility, Subject 1's blood pressure increased as well from the basal value, while Subject 2's blood pressure decreased slightly, and Subject 3's systolic blood pressure increased slightly from the original basal values. Figure 3 shows the changes in each subject's diastolic blood pressure. While listening to Beethoven's Moonlight Sonata, there is a decrease in each subject's blood pressure from their basal values. And while listening to the second song, Feeding of Nihility, there is a marked increase in the diastolic blood pressures in each subject from their original basal values. We used an ANOVA statistical analysis to analyze the results of our experiment, and through the ANOVA analysis, we determined our results were not significant enough to reject our null hypothesis. The ANOVA analysis shows that for heart rate, there is a significant impact on activity relative to the nature of the stimulus. The same correlation, although, was not found in the systolic or diastolic blood pressures. However, a qualitative reading of the data shows that mundane errors in method may have interfered with the statistical analysis of data for a diastolic blood pressure. The correlation proceeds as expected and as observed in the heart rate data, yielding reduced heart rates correlated with classical music and elevated readings with melodic grindcore. In addition, the changes in blood pressure were reduced in magnitude, which fed back to the percentage readings that were used in our ANOVA statistical analysis. This might be because changes in blood pressure are generally less acute physiologically than the heart rate fluctuation that we observed. Accordingly, ANOVA might not serve here to give us an idea of how the music affects blood pressure in the same way that a qualitative chart analysis would. In addition, there were no readings taken to assure that subjects sufficiently returned to their basal vitals before we reduced them to new variables. There is also the possibility of the placebo effect, which becomes complicated to quantify when dealing with experiments that rely on physiological responses. In conclusion, we found that while heart rate is affected by different types of music, further evidence is required to draw conclusions on the effects that music has on blood pressure. For future experiments, we should survey participants on preferred music, as it is a subjective preference and will skew our results. We should also allow enough time between variables for the subject to return to basal heart rate and blood pressure values and take readings to verify sufficient time between the runs. We should also allow more exposure time to the music to allow for a more thorough physiological response. And we should make sure participants remain still when specified, as movement during the recording alters the data and skews our results.